functions and inverses. So we remember what a function is. A function is a relationship between two sets, say set A and B, where each element in set A is related to exactly one element in set B. So let's look at an example. We have a set with 6, 7, and 8, and this is potentially a real-life example. These elements in A are children's clothing sizes, and the elements in B are the heights of children in centimeters. And our function will map 6 to 120, 7 to 120, and 8 to 130. Now, could we map 6 to 150? And the answer is no, because the definition of the function tells us that each element in set A is related to exactly one element in set B. And if we mapped 6 to 150, we would be mapping 6 to 2 elements in set B. So 6 cannot be mapped to 150, and this makes sense in real life as well. If we bought a size 6 in children's clothing, then we wouldn't want that sometimes it was 120 centimeters and sometimes 150 centimeters. So this is an example of a general function. And now we're going to look at inverse functions. So we have a set A with 6, 7, and 8. We have a set B with 120, 130, and 140. We note that we have the same number of elements in each set. And in this case, 6 maps to 120, but 120 maps back to 6. And the same with 7 and 8. 7 maps to 130, but 130 maps back to 7. 8 maps to 140, and 140 maps back to 8. So the black arrows are the function f, and the blue arrows are the function g. So this is the case of an invertible function. And note that we have the same set size, and we also have, as we said, 6 maps to 120 and always maps back to the same element in set A. And that's the case for each element. So we can think of an inverse function as undoing what our original function did, or the inverse function is the reverse of the original function. Now we look at this question. Are these two functions inverses? This is an algebraic example. We have two functions, f of x equals x plus 2 and g of x equals x minus 2. We can maybe guess that g of x might be the inverse because we've got x plus 2, and then g of x looks like it reverses that by subtracting 2. So the domain of x is 2 and 3, and the domain of g is 4 and 5. And we're going to approach this by calculating the composite function f of g of x. Now we're going to use as our inputs 4 and 5. So we're going to calculate f of g of x at each element in the domain of g, as g is the inner function and g's inputs must be in the domain of g. Now the reason we're calculating composite functions is that if we calculate f of g of x at x equals 5, and if we calculate f of g of x at x equals 4, for example, and we find that f of g of 4 equals 4, and we do the same thing for 5, and we calculate f of g of 5, and we compute that, and we find that f of g of 5 equals 5, then we know that we have inverse functions, that f is an inverse of g, g is an inverse of f. So we do that, and we calculate f of g of x at x equals 4. We first calculate the inner function, g of x equals x subtract 2, g of 4 equals 4 subtract 2 equals 2. We use the output of the inner function as input for the outer function, f of x equals x plus 2, f of 2 equals 2 plus 2 equals 4. And we have g of f of 4 equals 4. And in this case, so we have the x equals 4, our original input, and then we have f of g of 4 equals 4. And we notice that g, in the first step here, g mapped 4 to the element 2, and then f undid that, and we end up with our original input, which was 4. So we do that for x equals 5. G of x equals x subtract 2. G of 5 equals 5 subtract 2 equals 3. We use 3, which is the output of the inner function, as the input for f of x. 3 plus 2 is 5, and we find that f of g of 5 equals 5. So again, we have that the input 5, x equals 5, and we have that f of g of 5 equals 5. So we can say that f and g are inverse functions, and if we look at the sets, we have set A, which is 2 and 3, the domain of the function f, and we have set B, 4 and 5, which is the domain of the function g, and we have the case where the function f maps 2 to 4, and the function g maps 4 back to 2, and 3, the function f maps 3 to 5, and the function g maps 5 back to 3. So these are inverse functions.